Hello, my name is Fizzer. I'm the creator of WarLight, and I'm making this video to give a quick demonstration on how to use this AI framework that just launched. So this video is made to supplement this blog post that you're looking at right here. So if you haven't read this yet, you should read that first. The project I'm demonstrating is called WarLight.AI. And what this is a framework for developing and debugging WarLight AIs. You can download its source code, or you can, on this GitHub page, or you can go to the release tab. You can actually just download the zip file if you just want to run it. So if you download the zip file, what you'll get is you'll get this WarLight.AI.exe. This is a .NET console application. So what that means is if you're running on Windows, you have to have .NET installed to run it. If you're running on Mac or Linux, you have to have Mono installed. And if you run it, it'll print out this usage stuff here. So what this thing is this thing has the ability to play full games of WarLight. So it can either play against humans or it can play against bots. I'm going to show you how this works by first playing a game with it against myself. So I'm going to play a game against a human. I'm going to use this first usage of it here. And I'm going to tell it to create a game against myself. So if I run it, I'll do create. And then it asks for a bot name. So this executable actually has two bots inside of it. And they're basically they're both capable of playing WarLight games, but they're different. They're basically different AIs. So it has the prod AI, and the prod AI is short for production. That's the one that actually runs in WarLight.net today. All the games you played against an AI on WarLight.net have been against this AI. And the source code for this production AI is actually in GitHub if you want to see how that works. There's also this WonderWaff AI. This is written by a WarLight player named Norman for the AI games competition. And then I took it and I adapted it to work with WarLight's engine. So let's create a game using the WonderWaff engine against myself. So I create bot name, and then it wants the opponent email profile token. So I can give it my email address of my WarLight account, and that'll create a game against me. If you want to create a game against somebody and you don't know their email address, you can also give their profile token, which you can find in the URL when you're looking at their profile. And then we'll just come up with a game name here. And if I run that, it will actually create a game. So it created this game. It gives me the game ID. If I go to WarLight.net and go to the multiplayer section, you'll actually see it show up here. So I click on that. And what you'll notice is this is set up as a 2v1. And you can control the settings in the source code of this project. But I set it up as a 2v1 just because that way you'll give some actual challenge. So AI server bot is going to be the bot that's controlled by this executable application. And then it's teamed up with just a standard AI. And I did that just to give us a challenge, because if it's a 1v1, it would be way too easy. So if I join this game, I will actually be in a game against these two guys, and I can pick some stuff. I'm not going to think about this too hard. But if I do this, you'll see here this is actually printing stuff. It went through, and you can see the console output. It's actually weighting all these different things. So it's trying to figure out where it wants to pick, and it's making its move. So we can actually play a full game against this bot. So I'm controlling, obviously, my account, Fizzer. And this console app is controlling this AI server bot. And this AI is just a normal WarLight AI being controlled by the server. I also turned off fog in these game settings so we can actually see what it does. So this green guy is being controlled by my console app. So let's just commit some orders here, and we can see what it does. It started in a wasteland bonus, which is kind of dumb. So it still has a lot of work to be done. But this gives you an idea of how you can test it against a human. So another way you can set this up, you can control the settings for this game from the source code. But another way of doing it is you can actually just invite AI server bot to a game, which I will demonstrate. So if you invite this guy, so that all games that this bot plays against humans right now are just going through this single account. So you can only have one per game. But if you invite it to a game and then take the game ID back here, I'll show you the usage again. There's this second usage where you can just tell it to play an existing game. Now, if for whatever reason it crashed or something, I could have used this to resume the previous game if I just gave it the same game ID back. But I can also tell it to join an existing game. So I can just say I want WonderWaff to play this game. And it will actually go in, it will accept the invite, because I invited it to a game, so it has to accept it. And it will go in and actually enter orders for this game. So if I do something, we can see, there it goes. It go ahead, it entered orders. It's a fog game, so we can't see it, but just to give you an idea, you can invite it to a game. Let's see. So I can show you how this works in the source code. So if you download the source code, this is what you'll get. So this is just Visual Studio 2005 Community Edition. It's free. You'll see 3 folders once you open the source code. There's the common folder, prod, and WonderWaft. So these 2 folders are the 2 AIs, and then common just is kind of like the framework that makes everything work. So at the heart of everything is this interface called WarLight.AI. So if you want to make your own AI, you can either copy and paste one of these 2 and use that as a starting point, or you can actually just make your own class that just implements this interface. And it's a very simple interface. There's only 3 methods. There's init, which gives you a whole bunch of information about the game, get picks, and get orders. And depending on if it's during territory distribution, it'll call get picks. If it's not, it'll call get orders. Orders are things like deploy or attack or play a card. So it's very simple. You can implement this interface, and then you have an AI. It gives you all this detail about the game, such as your player ID, all the players in the game, the map, what cards you have, what orders your teammates have entered. All the information you need about the game is right here. Now, you can actually debug these games as well. So let's go back to that first game. And let's say the AI did something really stupid. Let's find something stupid it did. What did it do? Well, it didn't do anything too stupid, but sometimes it did pick Australia, which is pretty stupid. So we could actually go in and try to debug that. I'll show you an idea. I'll show you an example of how you would debug this. So you can, let's see, where was I? So what we can do is we can actually simulate the turn of a game. So there's this third usage of WarLight.AI here, where you can tell it to simulate. So we say we want to simulate a game, the WonderWaft AI. Now we can just give it a game ID and a turn number. And what it will do is it will basically go in and it will make orders for that game on that turn. So if we give it this game ID, now we could give it a turn number. Distribution is considered turn number 0. So if we want to see how it picked, we can just say 0. And it should, yeah. So it just recreated picks for this turn at this point in time. What we can do is if we take these and we put it in Visual Studio as the command line argument section, we should be able to just run that from Visual Studio. Yeah, it appears on my other monitor. So then what we can do is we can actually go in here and set a breakpoint on the, where is it? The expansion picks evaluator. So we can go in here and we can figure out why it's picking what it is. You just set a breakpoint, hit F5, and there we go. We're at the point where it's figuring out what it's got. So here's all the territories it picked and the weights. We could go through and walk through the debugger and figure out why it's weighting things, what it is. Like if we set the breakpoint here, we could say, okay, the expansion, it's going to walk in here. So right now it's evaluating Central Russia. It's like, what is the weight? How highly do I want Central Russia? And if you walk in here, you can see it's, oh shoot, I should have stepped into that. You can walk through the statistics of how it determines whether or not this is a good bonus. So this is basically an idea of how you would debug this. Is you could go back in here and you could figure out, like, why is it weighting this what it is? Why is it picking the way it is? And you can adjust these things and try to tweak it to make it smarter. That's an example of how you could debug this AI and incrementally improve it. Let's see. Another way of evaluating how good your AI is to play it against bots. Now, as I explained in the blog post, the primary goal of this project is to get an AI that's fun to play against humans, but yet it's still very useful to play against bots. So there's this other usage of WarLight.AI where you can just pass it the play AI command. So if I pass it play AI with the WonderWaff bot, it will actually play an entire game out on the fly right here. Now this is a different mode. Since we're not playing against humans, it actually won't show up on WarLight.net. This is actually happening just in memory on the AI server. And that's a necessary thing to happen because we don't want to have thousands of games polluting WarLight.net database. So what this is going to do is this is going to play the entire game out. And I set it up as a 2v1 again because a 1v1 is too easy for WonderWaff. A WonderWaff can beat the old AI pretty much every time. But with the 2v1, it actually struggles. Now, what this will do is it actually will write out the entire game. Okay, so the game finished. This is the game ID. 1 equals false, so WonderWaff lost this game. And if you look in the folder that you ran this executable from, you'll find that it created this folder called Play AI. And inside this folder, there's a text file for each game that's been played. Since this, you can see there's some that I've ran previously, but the one we just ran is this one on top here. So this text file is actually the entire game. So all the details of this game are inside this text file. And this is, in fact, the only place that this game is now recorded. It doesn't exist on any server anywhere. So if you want to actually see what this game looked like, there's a way to actually open this up and visualize it. And the way we do that is you actually go to WarLight.net, click on single player, and then there's a special secret button you can press to make this happen. And to access that, you have to open WarLight's debug menu. So while you're looking at single player, you just hold down Control and Shift and press E, and that will open up WarLight's debug menu. And there's this button right here called Import. This is basically a way to import a saved game, which is what this file is. So you click Import, it'll ask you for a file. You double click on that file we just created, and here you go. You can now see the entire game play out. So as I mentioned, this is a 2v1. This is the new bot. Ooh, that's a bug. This is the bot that our console app just played, and it's played against 2 traditional AIs. So you can actually walk through the entire game and see what happened. And it lost. Now, if we want to debug this, there's a way to debug this just like there was with the other human games. So let's find something it did that's stupid. Is there anything? Let's look at its first move. It's not completely stupid. Maybe it should have. It didn't even finish a bonus in 2 turns. Yeah, so it could have finished a bonus in 2 turns, but it didn't. It went for South Africa first, which even that it could have finished in 2 turns, but it didn't do that either. So what we can do is we can debug that. So let's say we want to debug turn 1 of this game. So there's this other usage of the WarLight.AI here called Play Exported. So this is considered an exported game. It's been exported onto our disk into this file. So we can do WarLight.AI. Let's get this command here. We want to play exported. The second argument was the AI type that we're playing is WonderWaff. And then it wants the folder name, and the file is located in the Play AI folder. So we actually just give it Play AI. It wants the game ID. This is the game ID right here. This is the file we wanted to play. And it needs the player ID. I'm basically just iterating through these arguments here. It wants the player ID. I have it on my monitor. It wants the player ID. And the player ID of the Play AI games, if we go into Play AI, here's the code that actually creates that game that we just played. You can see it's creating 3 players. It's creating the first one with me ID on team 1, and the next 2, which are just AI, is on team 2. Me ID is just this variable, which is player ID of 10. So we know the player ID in this case that we want to simulate is 10. So we want to be player ID 10 and the turn number 1. And if we do that and hit go, I misspelled WonderWaff, and it opens on my second monitor. If we do that, we'll actually just recreate that turn. So we just reran that turn. So if we look at it, we can see more about what it was thinking. Why did it expand the way it did? Well, It attacked Angola to Botswana with 5 armies. It attacked Angola to Nambia, Cameroon to Chad, Somalia to Sudan. And we could try to figure out, okay, well, why didn't you move into a position to take a bonus or something like that? We could see what executed these orders. For example, this Angola to Botswana was done by the calculate one-step expand bonus task. So like we can search for that in the source code, and we can then find where the part of the code that executed this move. If we hit F5 to debug that, it should drop us in right here, and then we can like try to figure out, why is it trying to take this? Well, it thinks it wants to take Botswana or Nambia, and you can walk through the code and try to figure out what it's doing. Basically, I'm just demonstrating how you would debug this. What I would usually do is I would set a breakpoint when it's doing something really stupid, and then figure out why it thinks it's doing that, make a tweak to the code so it does something better, and then just rerun it on the same turn, make sure it does something better at that point, and then just go play a new game and see if it's smarter. So that gives you a basic overview of how you would debug and develop an AI with this framework. A couple other things I'll mention is you will see these, where did I had it somewhere before, this player ID type thing here. I'll talk briefly about what this is. So if you make a function that takes a player ID, and say it also takes a territory ID or something like that, internally in the code, all these things are just stored as integers. So you could make a basic function that takes a player ID and a territory ID like this. One of the downsides of doing it this way is if you accidentally call this function, if you accidentally pass a territory ID where it expects a player ID, for example, that could be really bad. That could be a really subtle bug that's hard to find, because it might actually work correctly, right? You might accidentally pass a territory which is a valid player ID, and then you just have some weird subtle bug where something doesn't work correctly. So one of the things you'll see in this code is instead of passing integer player ID, it'll pass player ID type player ID, and it'll pass territory ID type territory ID. And all that does is it makes it so that you can't accidentally pass the wrong type to the wrong function. So like if you try to pass a player ID to a function that's expecting a territory ID, you will get a compile time error saying cannot convert from territory ID to player ID. It's just a simple thing to make it easy, make it harder to make that kind of simple mistake. If you do need a territory ID for some reason as an integer, you can always just cast it to an integer, and you can always cast an integer back to a player ID, as you see happening right here. So you'll see that. Yeah, so if you have any questions about this, feel free to contact me. We're going to be working on this a lot over the next few months. So if you're interested in helping out, I hope you find some enjoyment in this. Thanks for watching.